Hello and welcome to UiPath Essential Training, Data Manipulation. In this episode, we'll learn some basics about working with data in RPA projects. Hopefully, you're already familiar with control flow and variables from the previous chapter. Data handled with UiPath comes in many flavors, or types as we'd rather call them, and most often it will either be text, numbers, dates and times, lists, or tables. Data of all kinds is stored in variables and used in Visual Basic expressions to configure activities. All activity properties have predefined types and expect expression values accordingly. Types are visible on dedicated tooltips when hovered with the mouse. A type into activity, for example, has properties of different types, like continue on error, requiring a Boolean value, delays, expecting integers, and text accepting a string. Fortunately, we don't have to know such information for all properties. If we're using the context menu to add a new variable to a property, or pressing Ctrl and K, the variable is automatically created with the appropriate type. In this case, a string variable has been created. Now, most of the variables used with UiPath will fit into one of the following categories. Scalar variables, holding a single value of a fixed type, for example, characters, booleans, numbers, and date times. Collections, like arrays, lists, and queues. A particular case in this category is the string data type. As text is basically a sequence of characters, we may understand string as an extended type of a simple collection. Another special case is the dictionary structure. Dictionaries work like two synchronized collections of associated names and values that allow a value to be referenced by its name rather than its index. Dictionaries are used to pull data from orchestrator queues. The last category, tables. Tables are two-dimensional structures that hold data indexed by rows and columns. A table is similar to an array of dictionaries, where values are accessible by row index and column names. The generic value is a special type, entirely unique to UiPath, designed to simplify the use of basic activities. It can represent basic types of data, including text, numbers, and date or times. Using generic value is convenient, as the developers don't need to know or care about the type of data that they're dealing with. The downside is that you lose access to the default methods that are applicable to specific variable types. For example, the split method cannot be used with a generic value variable, but it will work for the string class. Using specific types also enables more precise expression evaluations. Arrays and lists in UiPath are very similar entities. The main difference is that an array has a fixed size, whilst the list can be lengthened or shortened by adding or removing elements. To define an array variable, we need to pick the array data type and then specify element's type. Optionally, we can give it a default value as a comma-separated sequence of items enclosed in braces. To define a list variable, we'll browse for the generic .list type and then pick the required content type. To initialize the new variable to an empty list, we'll set the default value to a new list, stating again the element's type in the declaration. We can optionally provide some content to the new list by using an initialization array, like this. Both lists and arrays may be iterated using a for each activity. Now we need to select the correct item type here. Let's use a log message activity and run the workflow to see the elements in the array. Check the output pane, and here they are. Now we'll change the loop to go through the list. There's no difference from array here, but a list has appropriate methods to add and to remove elements. To add a new element in the list, we need to use the invoke method activity. Now that requires the list object, the method name, and the new element specified in the parameters property. Careful that the element type should match the list definition. Now, if we run this again, we'll notice that there's a third value in the output pane, the one we just added. Dictionaries are generally useful when working with orchestrator queues, but they can also be used to hold multiple values in a single variable. For example, to reduce the number of arguments when passing data between workflows. To define a dictionary, we will browse for the appropriate type. The key type and value type need to be selected. Usually, the key is a string and the value is either a string or the more general object. To initialize it with values, we need to provide the dictionary constructor with an array of key or value pairs like this one. For adding data to a dictionary, a simple assign will do. The key name specified to the left and the new value to the right. Now, most of the data handled in UiPath is text, also referred to as string. Robots can receive text inputs from various sources, emails, files, or via screen scraping, and can generate text as output for applications, emails, files, and log reports. There's also a third scenario here which doesn't fall into the input-output categories. Text which is processed internally by the robot, like in the case of selectors, names, or file paths. To set an initial value for a string variable, we can type right here in the Variables pane. A string value is a sequence of characters enclosed in double quotes. If the text itself contains quotes, we need to write them twice, so they're not interpreted as string delimiters. This is a trick known as escape sequence. The newly created variable is now ready to be used in expressions. So let's try it with an if. We can build simple expressions with Visual Basic operators, or we can use some of the predefined methods of the string data type. Let's type dot after the variable name, and a list of available methods pops up. We have some pretty useful functions here, like contains, remove, replace, split, to lower, and trim. For this example, let's pick contains. This method returns a true or false value, depending on whether a word or phrase is found within a text. This is particularly useful in situations where the status of an operation is reported by an application-generated message with particular keywords, like success. To simulate how a robot would react, let's use two message boxes as action placeholders. If the message string contains the word success, the robot will follow the first branch, displaying the message, "Here would be more processing." Otherwise, it will go with the second branch, displaying, "Here we'd report an exception." Now let's run this. As you can see, the robot has reported an exception, as the word success is not contained in the message string. Now let's create a new variable called status, where we'll store the text from an application's status bar. Say, operation completed successfully, record number has been created. We'll use this variable for the condition and run the process again. Now this time, as you can see, the first branch gets executed. Let's extend our example and assume further processing is needed based on the record number created. We need an assign activity to build an expression that will help us retrieve that number. The split method is very useful to extract parts of a text when they are delimited by known markers. In our case, the number comes between spaces. The result of a split operation is an array of string values containing all the pieces between the delimiters. Using space as a delimiter, our example will return an array with 8 elements. The fifth one, with index 4, is the number that we're looking for. So let's define a variable for the result, parts, and then display the extracted number in a message box. Perfect. Split offers an alternative for achieving this extraction. In our example, the number is delimited by the words record and has. By pressing Ctrl plus Shift plus space, while the cursor position is between the braces, we can investigate more split options. We can use this one, taking in an array of string delimiters. Let's supply as argument to the split method an array with the words record and has. Notice that we have included the spaces in the markers as well. A second argument to the split method specifies if we want empty elements in the results, but in our case right now, this option doesn't really matter. In this new scheme, we expect the number to be identified as the second element, which has an index of 1. Let's check it though. And there you have it. While split method allows us to extract relevant parts from a larger text, there are common scenarios when various data needs to be assembled as text. For example, for logging or when we want to send out an email. There are two ways of doing that, with string concatenation or using string.format. To concatenate strings, we can simply use the plus sign. But if we need to mix various types of data, like for example integers and timestamps, they must be individually converted to a string. All data types have a default toString method that offers a readable textual representation. Let's display a message which contains a static text, followed by a string variable. And let's also append a timestamp. We'll use now, a date-time construct available in Visual Basic, which will convert to string. Let's run this. And there it is. As you can see, the date is displayed according to the regional settings on our operating system. If we want it to be in a different format, we must specify it as argument to the conversion. Now, there are many options and combinations available, most of them using one or more of these tokens as listed on the MSDN site. If we want to show the month, name and the year, we'll simply add 4 M's and 4 Y's. Now let's see. Hello World, March 2017. Great. Concatenation is handy and flexible, but if texts are long or if there's much data involved, the increasing complexity of the resulting expression may be avoided with the use of string format. Now, this method automatically converts data to text representation, and it also supports custom formatting. Let's see how our message would look. First, we set the frame text where data would be inserted. This is the static part. Now then comes a data placeholder, followed by another. And the numbers inside braces are the positions of data arguments coming right next, but indexed from 0. World, datetime, now. We can also customize the format for the date using the same tokens as before. Now, there are many string methods RPA makes use of. They're easy to handle and understand, so for quick reference, we've compiled a short list for the most commonly used. Checking whether a text contains a specific word or phrase. Checking whether a text starts or ends with a particular phrase. Assembling data in textual form. Replacing a word or phrase within a text. Splitting a text in tokens by known delimiters. Extracting pieces from text of known indexes and lengths. Changing text to lower or uppercase. Removing leading and trailing whitespace. Now, details about all the methods can be looked up on the Microsoft Visual Basic pages for string class. See the link in the video description. Data tables are very important structures, and they're extremely helpful when working with Excel or CSV files. There's a data tables chapter later in this course dedicated entirely to them. For now though, let's start building a short example to get our hands around the basic data table concepts. We'll use this CSV file containing tabular data for our automation workflow. The read CSV activity loads the data from the file into a data table variable. Let's call it sample data. We'll make sure that the option include column names is checked so that the first row is interpreted as the column names. To iterate through the data table, we'll use a for each row activity. To print the names of people in the table, we can use a write line activity. And to get a cell value from each row, we can pull from the row by the column name. The expression looks like getting data from a row dictionary. Running this will output each name in the table. Alternatively, if we want to see the value on the name column for a fixed row index, we'd have to write an expression like this, digging into the table like in an array of row dictionaries. Data table is a complex structure that has many handy methods. Select is a particularly useful one. This method goes through the whole data table looking for the rows that follow a certain rule and returns an array with the matches. Let's see how it works. We'll use an assign activity, specifying the table method used, and as arguments an expression that applies to the data table. Let's say age less than 40 and income greater than 40k. Next, we define a new variable to store the search results. By default, its type is set to generic value. The warning indicates that we need to change this, so we'll choose an array of data rows. To iterate through the array holding the search results, we need to use a for each activity. The rest, referring to the data within a column, is the same as before. OK, so let's display the name, age, and income using string concatenation. It looks like Paul is the only one who passed the test. Now this concludes our essential training on data manipulation. Today, you've learned about the most frequent data types and methods that you'll likely encounter in your project. Thanks for watching, and happy automation!